In this lesson, you'll learn a proven, step-by-step approach to finding and proving short-to-ground faults in automotive circuits, so you can avoid guessing and get straight to a confident fix. A short-to-ground means a wire or circuit has made unintended contact with ground, forcing voltage to drop near zero. This can cause sensors to read low, actuators to fail, or ECUs to log misleading codes. Recognizing these symptoms is the first step toward diagnosis. Before a short, the circuit delivers the expected voltage and signal to the ECU, letting it control or monitor components correctly. When a short to ground develops, the ECU sees a sudden drop in signal voltage, sometimes all the way to zero, and may log a circuit low or signal low DTC, depending on its fault logic. The ECU can't see a wire's physical path. It only monitors voltage at its input pin. If signal voltage falls below a defined threshold, the ECU flags a circuit low or short to ground DTC. These thresholds and logic can vary, so always check relevant wiring diagrams and service info for your system. With a multimeter, a healthy signal circuit will show the expected voltage reference to ground, typically around 5 volts or other design value. If the wire is shorted to ground, you'll see this voltage drop to nearly zero directly at the ECU harness pin or connector. Comparing these actual readings to what you expect based on wiring and function is key. Scan tool data reports what the ECU sees. For a short to ground, the scan PID will show a constant low value, or may even freeze at a minimum. However, this does not confirm whether the fault is inside the sensor, the circuit wiring, or a related shared reference. Always compare scan data to direct meter readings at both the component and the ECU to pinpoint where the voltage drop really happens. Many techs replace sensors or modules when a circuit low code is present, but the real problem is often a pinched wire or connector short to ground. Swapping parts before confirming the short with voltage or resistance measurements wastes time and money. Prove the fault's location before replacing anything. Start by mapping the circuit with a wiring diagram. Check voltage at the ECU pin and at the sensor connector. If voltage is near zero at both, disconnect the sensor and see if voltage recovers. If not, unplug harness branches one at a time, watching for voltage change. Use continuity tests from the shorted pin to ground, while connectors are unplugged, to pinpoint the fault. Always confirm the short before repair. Short to ground faults create symptoms and scan data that can mislead. But by following a methodical measurement and comparison sequence, you can isolate real wiring faults and avoid unnecessary parts replacements. Always verify with both scan and direct circuit checks before every repair. You now have the tools to diagnose short to ground faults with confidence. Always start with system understanding, confirm with measurements, and act on proof, not assumptions.